So we're going to do a demonstration of basic operation of the FEI Tecnai F20 TEM. So to start with, we have the airlock here, and you can see we have the single tilt holder inserted already in the column. This is where we keep the single tilt holder when it's not actively in use. And then over to the right here, that metallic cylinder is a cold trap, and that is filled with liquid nitrogen. And so what that does is it acts as an anti-contamination device. So it has a series of copper braids that feed from inside the dewar into the column. And obviously, because they are immersed in liquid nitrogen, they become very cold, and so they provide a good surface for contamination to stick to inside the column. And so that helps to keep the specimen from contaminating when we are imaging it. It also helps to keep pressure in the column down as well. It does not actually cause any chilling of the actual TEM specimen, though. Okay, so it's not a specimen control, a temperature control. It's merely a contamination temperature control. And so with that, we can now discuss how to remove the holder from the airlock. So next we're going to talk about how to remove the holder from the column. So the basic idea here is I have this purple plate right here. I'm going to use my left hand and gently push against that purple plate. And then with my right hand here, I'm going to grab the single tilt holder by the base here. I'm going to pull straight out till I feel stop, then turn clockwise till I feel stop, and then I'm going to pull the holder straight out. So again, it's pull, clockwise turn, and then pull out. So it looks like this. Pull straight out, turn, and then pull it out. Okay? And now we can discuss loading the grid into the holder. Okay, so I'm over here at the table where we set down the holders and load the grids into and out of the holders. So you can see here, this is the support base for the single tilt holder. We have another one for the double tilt holder. This is the single tilt holder. You can see here, right over here, there's a slot in the base here. Okay, if you go over here now to the support base, you'll see right here there's a little pin. Okay, so I have to line up the holder with that pin on the support base, okay, so that slot in the base goes into that pin, okay, like that, so now it won't rotate. Okay, so now I can sit down. Okay, I uncover the end. There's a special tool here used to open up the end of the holder. Okay, so down here there's a little place for this pin to insert. Okay, flips it up, and then this is where we place the grid right here. So we have a classic TEM test specimen. It's gold nanoparticles on an amorphous carbon support film on a copper grid. Okay, so I'm going to go ahead here, use a sharp pair of tweezers. Okay, there we go. It's probably hard to see, but this is actually the darker, shiny side of the grid. You want to place that down into the holder, because that's the side of the film that has your particles on it. Okay, so I'm just going to set this down here. Okay, and then I can use my tweezers. Okay, so it's centered in the basket there. I flip that down. Put my tool back here. Cover the tip back up. Cover my tweezers back up. Now we are ready to load this into the column. So next we're going to load the holder into the column. So to start with, we're going to look at the holder here. And we see here on the shaft we have this pin. So when we load the holder into the airlock here, we have to line up that pin with this line right here. So I'm going to line up that pin with the line, And I'm going to push the holder all the way in, and it's going to go up basically to the edge of that tape line right there. As it gets close, there's going to be some resistance that I have to push through because there's a seal. Okay, and then once it's in, I'm going to let go of the holder so I don't accidentally cause a vacuum crash. And I'm going to line up here with the pin with the line, push, and then let go. Okay, you'll notice this red light comes on, okay, meaning the airlock is being pumped out. While that's happening, I'm going to come over here to microscope control, and I see down here the system's asking me what kind of holder I have. I have single tilt, so I select OK. And if my turbo pump is at full speed, then this will take approximately 1 minute. And when it's done, you will hear the valves close, indicating the airlock is done being pumped out, and you will see this light turn off. Okay, so shouldn't be too much longer, about 10 more seconds. Alright, so there's the valve closing and there's the light going off. So now I have to rotate the holder counterclockwise until it stops, and then the vacuum is going to pull the holder in, and then I can gently push on the end of the holder just to guide it all the way in. Again, I take my hand here, counterclockwise rotation until it stops. Okay, and now we have the holder inserted into the column. Okay, so there's a couple things we need to do here before we get started. So if we go into the beam tab here, we can do a couple things. So the first is to apply the gun alignment. So the gun alignment on this instrument is very stable and doesn't need to be adjusted on a day-to-day basis. Okay, so all you need to do is select this label here which says GL3 and then hit set, and that applies the gun alignment. The other thing we can select before we start is the spot size. Again, numerical value here. And so for pretty much all conventional imaging, we want to use spot size 1 because that gives us the highest current. Okay, and so it's already set at 1, so we're not going to adjust it any further. Okay, and so then we're ready to move on to opening up the column isolation valves and looking for an area of interest. So this is a field emission gun instrument, which means that the beam is always on. So what we have to do is we have to open up a pair of isolation valves that allows the beam to travel from the gun through the column, through the sample, and then on to the viewing screen. So we're going to go here in microscope control to the startup tab, and in the vacuum panel select column valves closed. That opens up our isolation valves and it turns off the turbo pump. You don't want the turbo pump on when you are imaging because that is a source of mechanical vibration. So now we're going to come over here to the viewing screen, take off our screen cover, and if nothing is in the way of the beam, we should see an image, and we don't right now. And what we need to do then is navigate around here until we can see something. So if I look here in microscope control, it's telling me right now I'm in SA mode, and that's my indicated magnification. So what I'm going to do here is in my right hand panel, I'm going to use my magnification knob and I'm going to decrease my indicated magnification until I'm into LM mode. Okay, so SA mode is the mode you use for general imaging, but now we're going to decrease this. Okay, we go into M mode, and now we're in LM mode. Okay, I'm going to go about like this. So now we're going to come back over here to the screen, and now we can actually see some intensity on the screen. So we were over one of the grid bars on the grid, which is why we couldn't see anything. Okay, and so now I can come over here to my left hand panel right here, and by using my intensity knob I can expand or contract my area of illumination. Okay, so there we go, we're expanding it. I can shift the beam position around using this trackball. This is a dedicated condenser deflector shift function trackball. Okay, so again, I'm moving it around here. And so now what I want to do is I want to find an open area of the grid, because obviously if we're over one of the grid bars, we won't be able to see anything. I'm going to move that to the center of the screen. So I'm going to move that over here on my right hand panel using my joystick. Okay, so if I come back here to my image, okay, so now I have an open area in the middle of the viewing screen, and then I'm just going to come back to my magnification knob, and I'm going to go back into SA mode. Okay, and now my beam is a little too spread out, so I'm going to come back to my intensity knob. And decrease my area of illumination. Okay, so there, now I have my area of interest selected, and it looks like I don't actually have anything here. And sometimes that happens with these support films, is some of the support films end up getting ruptured. So what we're going to do here is we're going to go back into LM mode. Okay, we're going to look for an area that we think has something in it. Ah, okay, there we go. All right, right there. All right, I'm back into SA mode, and so now we can actually see that we do have something here. So again, these are the gold nanoparticles on amorphous carbon. They are deposited in such a way that they develop this array of squares, a square shape pattern on the grid, and that's what we're seeing right now. Okay, so now that we have our area of interest, we need to set it at Ucentric height. So if I come over here to my right hand panel, I'm going to push this button that says Ucentric focus. That sets my objective lens to the proper setting at which, when the sample is at Ucentric height, my image will be focused. When I'm doing this, here in microscope control, I want to make sure I'm in SA mode, and I want to use a magnification of 13,500x indicated. Okay? If you go too high with the indicated magnification, this is actually counterproductive in terms of setting the specimen height, and obviously if you go too low, then it can also be counterproductive. So this is a nice middle of the road value to use when doing this. Okay, so if I come over here now, okay, I see my array of squares on my support film, and clearly I can see them, so that means I'm in contrast, so I'm not at Ucentric height. So if I come back over here to my right hand panel, I have a Z-axis control. I'm going to adjust this until my specimen is in focus. So I don't know which way I have to go. I'm going to start by just holding down and seeing if I get any better. Okay, so I'm holding down. You'll notice there is a little bit of lateral movement of the image. That's not really problematic, except if you're trying to set this on a specific feature, in which point you need to use the joystick to recenter it periodically. But you see we're not really getting any better, so I'm going to hold up now. And looks like we're getting better. Again, we're looking for minimum, oh, right about there. Okay, so you can see the grid lines basically disappear. If I keep going up, I can start to see them again. So I've gone past Ucentric height. I'm going to go back down. And right about there. Okay, so now I'm at Ucentric height. Okay, so the next step in the alignment procedure is aligning the C2 aperture. So I'm going to adjust my indicated magnification to 86,000x. Okay, and now I'm going to bring my beam to crossover with my intensity knob. Okay, right there. I'm going to expand it from crossover clockwise by turning the intensity knob clockwise, meaning I'm over focusing. And now I'm going to use my beam shift trackball to center it on the viewing screen around that small 4mm circle in the middle. Then I'm going to take my intensity knob and expand the beam again, turning clockwise. So we can see now it's not expanding concentrically with either of those circles. Okay, so I expanded it so it was a little bit bigger than that bigger circle, which I believe is 40mm. So because it's not concentrically expanding, this means the C2 aperture isn't aligned properly. Okay, so if we come up here, this is the C2 aperture strip. Okay, so right now you can see, okay, this is the setting right here. So this has 4 different apertures, 1 through 4. 1 is the smallest, 4 is the biggest. 2 is the default position that's used for pretty much all conventional imaging. Okay, you can tell because that's where the pin is set. So we're not going to adjust the aperture itself, okay, in terms of which one we have selected. We're going to adjust its position. Okay, so this knob here is a position adjustment, as well as this knob here. Okay, so if we come back down here to the viewing screen, okay, so now what I'm going to do is use my aperture shifting knobs to shift the beam so it's centered again. Okay, so I'm going to do this one knob at a time. Okay, so that actually looks pretty good. I'll make an adjustment with the other knob. And now I'm actually centered again. Okay, so this is something you should do a couple iterations for. Okay, so I'm actually going to go back to crossover, expand clockwise, use my beam shift trackball to center again, and then expand. Okay, so that actually looks better than it did, but probably still off a little bit. So I'm going to adjust this again. Alright, and then I'll do one more iteration here. Or crossover, expand clockwise. Okay, and so our C2 aperture is now properly aligned. Okay, so the next step in my alignment procedure is adjusting the condenser astigmatism, or correcting it. Okay, so we're again checking to make sure that my incident beam is round, okay, circular. So right now, based on how we have it expanded, it doesn't look, it looks circular, okay, it doesn't look very astigmatic. But if we go closer to crossover here, we can actually see that it takes on a more elliptical shape, okay, when we're doing this. Okay, so I do have some astigmatism in my incident beam that's a little more readily evident when I'm closer to crossover. Okay, so how do we fix this? We come over here to microscope control. Okay, I go into the tune tab up here. Okay, down here I have a astigmator control. I select condenser. So what this does now is it activates on my right panel my multifunction Y knob, and then over here my multifunction X knob. Okay, so these are activated now to adjust my condenser stigmators. So I need to adjust those until I have a round beam. Okay, so what does this look like? Okay, you can see here, oops. Alright, so now I don't really have any astigmatism left. Okay, so that's what you want. And we're done correcting the condenser astigmatism. My next alignment step is to balance my condenser deflectors. Okay, so I'm again going to come over here to my microscope control. I'm in the Tune tab again. Under Direct Alignments, I select Beam Tilt PPX. Okay. If I look on the viewing screen here, I can see the beam is now separated. Okay, it's oscillating back and forth. So if it looks really bad, it looks like this. So now my multifunction knobs are again activated to adjust this. I'm going to use multifunction X and Y, usually the X mainly, okay, to minimize that oscillation, just like that. And then I have to do the same thing for the Y pivot point. So I come back here, okay, I'm done with that alignment, so I hit done. Then I select beam tilt PPY, okay, and I do the same thing. Use my multifunction knobs, minimize separation of the beam, right about there. And then I'm done. So next we're going to perform rotation centering, make sure our incident beam is aligned with the optic axis. So I'm going to come over here to microscope control. Okay, I'm in the tune tab. I select rotation center. Okay, you'll see now my image is pulsing in and out of focus. Okay, usually helps when you do this sometimes. I'm going to expand the beam so we're not quite as close to crossover, okay? And we're not concerned with the motion of the beam, we're concerned with the motion of the image. Okay, so you can, hopefully you can see that, but my image motion, okay, is occurring, meaning my rotation center is not correct. So again, I'm going to use my multifunction knobs to minimize that movement. Okay, so again, I'm going to use X and Y here. That's worse. Alright, and there my image shifting is basically gone. Okay, that's what we want. So rotation centering is done. Come back here to microscope control and select done. So the last step in the alignment procedure is aligning the objective aperture. So the first thing I'm going to do here, I'm going to adjust my area of illumination so I'm a little bit bigger than that 40mm circle. This corresponds roughly to the area of the CCD pixel array. Okay, so that gives us maximum efficiency in terms of signal. Okay, probably also means we're deviated from parallel incident beam, but again, we're not really concerned with that. The main concern is getting enough signal. Okay, so I've got my area of illumination, okay, set. Now I need to go into diffraction mode to align my objective aperture. So I come over here to my right hand panel. Okay, I see a button there that says diffraction. I push that, I go into diffraction mode. Okay, so you can see now here, right, I have D for diffraction and I have camera length. Okay, so if I take my magnification knob, that adjusts my indicated camera length. Okay, now if I look on the screen here, and that might be a little hard to see, okay, probably a little really hard to see, but I have a polycrystalline diffraction pattern. Okay, so now I need to insert my objective aperture and center it around the direct beam. Okay, so this is the objective aperture strip again. Turn the lights on. And so this actually has 7 positions. If you come around here to the side. Okay, so right now it's out. Okay, and so we keep it out when it's not in use. So positions 7 through 5 actually don't have any apertures. It's not till we get to 4 here that we have an aperture. And then 4 is the smallest, 3 is the next smallest, then 2, then 1, so 1 is the biggest. Okay, so we're going to use 2 today. That's the aperture that's closest to the ideal size to give us optimal resolution. Okay, so I'm going to just turn this knob here. Okay, so you can see that pin here on this knob is now lined up with 2. Okay, so what we have to do now is center this aperture. Okay, so that might be a little hard to see, but I can actually see the rim of my objective aperture. Okay, it's actually misaligned and it's blocking the direct beam. So I'm going to use my aperture shifting knobs again. Okay, so there I'm not centered. Ah, there we go. Okay. I can center my objective aperture around my direct beam. So this is actually done most effectively using these binoculars and the aid of the focusing screen. Okay, so right down here, I flip that bar forward. Okay, and that little screen right there, okay, that is the focusing screen. So these binoculars are actually looking straight at that screen, and that actually gives me a more magnified view of the diffraction pattern and my objective aperture that allows me to position it really, really accurately. Okay, so that's actually what I'm going to do here when I'm done with this part. I'm actually going to use those and get a nice, precise alignment of my objective aperture. Okay, so my objective aperture is aligned. So now I'm ready to go back to image mode and collect an image on the CCD camera. So I come back here to my right hand panel, select diffraction, and now I'm back in SA mode. Okay, so if I come back here, let me get the focusing screen out of the way. Again, that's how big I want my area of illumination, because that's roughly the size of my CCD array. Okay, so we've got the alignment all done. We're now ready to acquire an image with our digital camera. Okay, so again, we want the beam this size as viewed on the viewing screen, a little bit bigger than that 40mm circle, because that's roughly the size of the CCD camera array, pixel array. Okay, and again, we're always expanded from crossover by turning intensity clockwise. So again, over focusing C2. Okay, so now the camera is under the viewing screen. So we have to insert the camera, and then we have to lift up the viewing screen so we get that image down to the camera. Okay, so in order to do that, right, I come over here. First thing I'm going to do, actually, I'm going to cover the viewing screen, okay, to prevent any ambient light from getting to the camera and interfering with it. I'm then going to come over here. Okay, I'm in the camera tab here, hit search. On this right monitor here, that starts a live image. Okay, I don't see anything yet. And the reason for that is my viewing screen is still down. So now if I come over here to my right hand panel, select R1, that flips up the viewing screen, and now I have an image. Okay, so again, this is the gold on carbon. We can see those dark areas are the gold particles, and then the lighter areas are the amorphous carbon support. So this defaults to an exposure time of 0.01 seconds. If I click on the image and then I hit the up arrow, that will double the time. So now it's 0.02. Now it's 0.04. Now it's 0.08. Usually that's sufficient for viewing the live image. If you go any longer than that, you do improve your signal to noise, but your response time is a lot slower. So in other words, if I wanted to move around here, okay, so I'm using the joystick here to move, right? You can see, okay, but let's say I make my exposure time. Okay, so now I doubled it twice, and now I'm at 0.32. So now watch what happens. Okay, so my response is just, it's slower, even though my signal to noise is better. I'm going to go back to 0.08. And there it is. Okay, so now what you can do here in your digital image is finally adjust the focus. Okay, you should always do this in your image that you're viewing digitally. Okay, so to do that, come back here to the right hand panel, and I have the focus knob. So this outer knob is a strength of adjustment. So this has 9 different settings. If I look here, okay, I can see my focus step, which is 5. Okay, I usually don't need to go that high, usually 3 or 4 at most. So we're going to change this to 3. And then we're going to come back here to the image. Okay, so we can actually see here in the image, I don't know how easy that is to see, but I can actually see a light fringe around the edge of the particles. So I am a little too under focused. So I'm going to turn my focus knob clockwise to strengthen the objective lens. Okay? Right, so I'm going clockwise. Okay, and so right about there, I have pretty good focus. I have a slight under focus, not too much. If I keep going, now I'm over focused. Okay, and that's no good. Right, so here I'm going to come back. Right, so right about there is what I want. And again, if I go really, really high with the under focus, right, it becomes much easier to see that light Fresnel fringe. And you can also see a little bit of image delocalization. Okay, but that's pretty good right there in terms of the focus. So now when I have my focus set how I want, I can record a final high quality image. So this live image is 512 by 512 in terms of its pixel dimensions. So my final acquired image will actually be 2048 by 2048. So over here, I have an exposure time for my final image. I hit start acquire. Usually 1 to 2 seconds is plenty sufficient here. Hit start acquire, new window is pulled up. Okay, and there's my final acquired image. And this is again 2048 by 2048. This is the full pixel array of the camera. Okay, so go ahead and delete that. Whoops. Okay, so if I want to change the magnification I'm working at here, okay, you always want to do this not looking at the digital image. Okay, but you want to do this looking at the viewing screen. So I'm going to come back over here. I'm going to flip the viewing screen back down. Open up my viewing screen cover. Okay, and so now I can adjust my magnification. So I'm going to go up here a couple settings. Okay, so I went to an indicated mag of 125,000x. And so now obviously I need to resize my beam. Okay, so there, I've resized it appropriately. Okay, and now we're ready to cover the screen, lift the screen back up, and then get the image back on the camera. Okay, so go ahead and cover it here. Hit R1. Okay, and there is my magnified image. Okay, so it's probably a little easier to see here. Okay, the light Fresnel fringe around the edge of the particles. So there I'm under focusing, right? You can see it's pretty distinct. And then right about there, okay, that's right about what I want in terms of the focus. And then if I go worse, I can see the dark fringe, okay, the dark Fresnel fringe. So right about there looks good. And then I can do an acquire here. And there I have a final image. Okay. So one thing we're not going to discuss in this demo is adjusting the objective stigmators. We will discuss that when we discuss high resolution imaging. Okay, because that will be a separate topic. There's a very specific way to do that. Okay. So now when you're done using the digital camera, we need to stop the image acquisition and retract it, and then flip the viewing screen back down. So I come back over here to microscope control, and I just select insert here, that stops the view and pulls the camera out. Okay? And I can come back over here to my viewing screen. You can see the screen's lifted up. Okay, flip the viewing screen back down. Okay, and again, I'm done using the digital camera. So a couple other things we can demonstrate here really quick are the effect of changing the numerical value of spot size on my beam current as well as my beam size at crossover. Okay, so right now I'm at spot size 1. If I come over here now to the beam tab, okay, let's go from 1 to, we'll go to 8. Okay. So now I'm going to adjust my intensity knob to get my beam the same size that I just had it. Okay, and it's there. Okay, so I'm illuminating the same area that I just did. Okay, but obviously I lost a lot of current by going to a numerical value of 8 for the spot size. Okay, which is exactly as we would expect. So my semi-angle of convergence isn't any different. Okay, my C2 aperture is the same. I had to adjust the C2 lens when I changed the numerical value of spot size to get to the same area of illumination and the same semi-angle of convergence. Okay, so the only thing that changed ultimately as a result of doing this was the beam current reaching the sample. Obviously that's not very good in terms of the signal we can generate. So we never use a high spot size when we're doing conventional TEM. Okay, pretty much never. So one of the things we can also demonstrate is the effect of numerical spot size on the physical size of the beam at crossover. So I'm back at spot size 1 here. Okay, that's my beam size at crossover. Okay, and there I'm expanded. I have to do this kind of quickly because at crossover the camera doesn't like it and it doesn't focus well. Okay, and there I'm at crossover. Okay, so now if I go again here in my beam tab, I go from 1 to 8. There I'm at crossover. Okay, and you can see there I've made a smaller beam, okay, which is exactly what we would expect. Okay, when you go to crossover at higher numerical spot size, your beam size at crossover should be smaller. Okay. So this has implications when we're doing things like scanning TEM, which we will get to in another demo. Okay, so if we're doing high resolution scanning TEM, you pretty much always use a high numerical value of spot size. But for conventional imaging, there's very little applicability to that. Okay, so when you're done with your TEM session, come back over here, and we go back to the startup tab. We close the isolation valves. Okay, come back over here, cover the viewing screen. Okay, we take out the objective aperture here. You don't want to leave this in before we initialize the stage, which is what we're going to do next. And then we're going to come back here to microscope control, go to the stage tab, expand this little flap out, and select holder here. Okay, that's going to reset all the stage coordinates to 0, at which point then we're ready to take out the holder. Okay, and so right down here in the info panel we can see all of my positions are basically zeroed out. Okay, and now we are ready to extract the holder. Okay, so we're done with our TEM session. The holder's been retracted. Now we need to remove the grid from the holder. So again, I've put the holder into the base, got my special tool here, flip open the end clamp, And now to get the grid out of here, the best way to do this is not with a pair of regular tweezers, but with a pair of vacuum tweezers. Okay? So again, these work by vacuum suction to pick up very light things like TEM grids. All I'm going to do here, okay, I turns on the little pump, which is essentially a fish tank pump. This is the vacuum wand. If I cover that hole with my finger, I now have suction at the tip there. Okay, so I can use that to pick up the grid out of the basket. Okay, and so this is a far more gentle way to get the grid out than by trying to use tweezers. Okay, I'm going to open up my grid box. Okay, you can see I've picked it up. Goes back into my slotted box. And we're all done. Okay, now at this point, I'm not going to go through it because we already went through it before, but I would put the single tilt holder back into the column, and then I would be through with my session.